Okay, this is the last one for this podcast. And we're 7x plus 6. And notice that this one we could not factor out a greatest common factor. We can't even use factor by grouping because we only have 3 terms. And you can only use factor by grouping with 3 terms if it's a quadratic. So we're going to use a rational root test. If the function has rational roots, then the rational roots will be some factor of our constant term divided by some factor of the leading coefficient. So our constant term is 6 factors, positive, negative 1, positive, negative 2, positive, negative 3, positive, negative 6. And of course, factors of 1 is just positive, negative 1. If you use long division, then you would divide by x minus 1, x plus 1, x minus 2, x plus 2, x minus 3, x plus 3, x minus 6, x plus 6. If you use synthetic, it's going to just be your solutions. 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6. At least one of those is going to work because we're going to have at least one rational root. Actually, a cubic has to have at least one real root. But I do guarantee you'll have at least one rational. All right, on the next page, let's do some division. I think you have all of that on yours. So we're going to use 0 to hold the place of missing terms. We're missing the x squared. So I'm going to write that because this really should be an equation. Y equals x cubed minus, 0x squared. Or plus 0x squared. It really doesn't matter if you're 0. And then minus 7x plus 6. Right? So for synthetic, we represent the coefficients 1, 0, negative 7, 6. And we use one of our factors from the other page. Let's go with 3. Let's try 3. Negative 6. Right, so let's try this one. Bring down the 1. 1 times 3 is 3. Add, I get 3. Oh, by the way, if you want to wait to write it down, that's fine. To see if I've messed up. And I'm going to have 6 plus 6. So don't write that down. However, let's try negative 3. All right, so bring down the 1. And you can wait until we check and see if I'm right. 1 times negative 3 is negative 3. Add, we get negative 3. Negative 3 times negative 3 is 9. Add, we get 2. 2 times negative 3 is negative 6. And that works out. I got 9 when we had positive 3 as well, and I would have had a 6. So, but negative 3 works out perfectly. Now we can factor the rest. Remember, this is the remainder, constant, x and x squared. So we have x squared minus 3x plus 2 equals 0. 1 times 2 equals 2. We need two numbers that multiply to give us 2, but add to give us negative 3. That's going to be negative 2 and negative 1. Right? These multiply, those add. So every time, by the way, when you're factoring, it's the exact same steps. It's never any different. We just replace the negative 3x with negative 2x and a negative x. Don't forget the plus in between. And the first two become a group and the second two become a group. We plot our greatest common factor. And so for x squared and negative 2x, it's x. Divide both of those by x. We have x minus 2. Divide negative x and 2. Greatest common factor, of course, we want it to match x minus 2, so we're going to have to factor out a negative 1. All right, so we factor out the, I didn't leave myself much space, but I'll just keep on going to the right there. We factor out the repeating x minus 2, and we're left with the leftovers, x minus 1. And so now we'll set those equal to 0. X minus 2 equals 0, x is 2. X minus 1 is 0, x is 1. All right, so we have 3 solutions. Don't forget the one you used for dividing. We have 2. We have 1. Don't forget you have x equals negative 3. That was a factor because the remainder is 0. Right? So x equals negative 3 is a factor because the remainder was 0 when we use synthetic division. All right, so we have our 3 solutions. We need our turning points and our y-intercept. And then we just graph. See how easy this is? Easy cheesy lemon squeezy. If you're focusing on the steps, if you're thinking about them, right? If you're not doing something else while you're watching me, this isn't too bad. And don't ever do something else while you're watching me, otherwise you're not learning at all. Right? And so we have our x-intercepts. We're going to divide the graph into intervals and choose a test point in between each to graph. We have a lot of numbers in between -3. Right? We have -2, we have -1, and we have 0. No point in necessarily using 0 because we know what 0 is. That's going to be our y-intercept. I don't know if I left a space over here to do it or I just plucked the y-intercept on the other page because it's so easy. Yes, I did. Just plucked it on the other page. Or write it over here. You see it's 6, right? That's because if you plug in 0 for x, the only thing left is the constant. So f of 0, that's 6. That's our y-intercept. So we won't bother to use that for our turning point because we already know what it is. Let's check the other ones, -2 and -1. You don't have a lot of choices between 1 and 2. It's going to have to be a half. Right, so let's use -2. Right, so we have 1, and don't forget this was x cubed, and this was plus 0x squared minus 7x plus 6. So by the way, you can use fractions for evaluating, just finding the value of something. You cannot use fractions, though, to find a root. All right, for synthetic division, for finding your x-intercepts, it has to be x plus or minus a constant. And that reason is you end up losing that leading coefficient when you're, because if it was 1/2, remember that's really, the factor would be 2x minus 1, you end up losing this leading coefficient and it messes everything up. It doesn't matter for evaluating, all right? We're just plugging in 1/2. It only matters for when we're factoring. All right, so, let's bring down everybody else. 1, 0, -7, 6. All right, now let's divide. So bring down the 1. 1 times -2 is going to be -2. Add, we have -2. -2 times -2 is 4. Add, we have -3. -3 times -2 is 6, and that is 12. Right, so we have the point here, -2, 12. Let's see what happens when we plug in -1. So same thing. Should have wrote a little smaller. So I still got to fit the 1/2 in there somehow. Right, and so we have, again, 1, 0, -6, and 6. You can move up. Oops. I hate when that happens. Then I get these little stupid boxes around things. All I want to do is just move them up in the right spot. Right, bring down the 1. 1 times -1 is -1. Add, we get -1. -1 times -1 is 1. Add, we get -6. -6 times -1 is 6. Add, we get 12. Could that possibly be? Did I make an error? Or is our turning point halfway in between? You don't usually get that on a cubic. It's possible. But it's usually our quartics are so symmetric. Let me just double check. -2, -2. 4, -3. 6, 12, yes. 1, -1, -1, add, we get -1. Is 1, add, we get -6. How about that? So, guess what? We need to plug in one more. So, I said we won't plug in fractions unless we have no other choice, but we will if both integers were the same. It doesn't often happen on the cubic, but it happened here. Right, so we're going to move everyone over just a wee bit, so we can squeeze in the last two divisions we have to do. So we're going to divide by, but halfway in between -2 and -1 is -3 halves. Sorry for that. Why is that all like funky? Did I just lose somebody? Let me just double check. Make sure, no mistakes. Right, so, oh, I know why. I just pulled everybody over too far. Never mind. He's supposed to go here. So 1, -1, -6, 6, 12. All right, so we'll plug in the -3 halves. So if it does happen that they're both the same, you do have to plug in the midpoint. So 1, 0, -7, 6, because the last thing you'll do, there'll never be a straight horizontal line in our quadratic functions. They're all curves. So we know that it has to go someplace. So we're down to 1. 1 times negative 3 halves is going to be negative 3 halves. Add, you get negative 3 halves. Multiply, you get positive 9 fourths. Negative 7 is negative 28 fourths. Right? 7 times as much. And add those together, you're going to get negative 19 fourths. Multiply, you're going to get, right, so 3 times 9 is going to be 57, 1957 eighths. So we're going to have positive 57 eighths, and 6 is 48 eighths. So if we add those together, we have 105 eighths. So in between our negative 212 and our negative 112 is the point negative 3 halves 105 eighths. And that is a smidge, just a smidge more than 12. So this one here, this is our turning point. But we're going to graph those other points because they're easy to graph and that'll make our graph look better. Let's find our last turning point, and the last turning point is in between 1 and 2. This one we just have to do a half. And so one more time, I really should have written smaller. 0, 1, negative 7, 6. I have just like no space. There was really no, here we go. I'll just make my house a little smaller. Get rid of this point. Move everybody up. Oops. Not that far. There, now we have a little bit of space. All right, so bring down the 1. 1 times a half is a half. Add, I get a half. Multiply a half times a half, we get a fourth. Negative 7 is negative 28 fourths. Can you read that? Not really. That's me saying that. Let's see if I can write that a little nicer. And then I'll just kind of squeeze them in there. So negative 28 fourths. I'm going to have to move that up a little bit more. Man. Whoops, not the this one's, woo, no. All right, well, yeah, you have to move up this right here. There we go. Okay, that gives us a little bit more space. Then you can see the negative 28 fourths. Right, and we've crossed out that 7. So negative 28 fourths plus 1/4 is negative 27 fourths. All right, hopefully no mistakes here. All right, negative 27 fourths times 1/2 is negative 27 eighths. And 6 is 48 eighths. And so if we add those together, we'd have to subtract. It would be negative 21 eighths. All right, so we have one turning point. It's a maximum at negative 3 halves, 105 eighths. The second one is at, it's a minimum, 1/2, negative 21 eighths. So some interesting points on this one. So this one is the other turning point. But we will certainly graph those other points that we found. All right, so here we had to check a little bit more than we did on the other ones, just because there's more values in between them, and then we got the same value twice. And there's all our points written down. All right, so, oh, did I make a mistake? Back here. Oh, I'm sorry, we're looking between 1 and 2, not 0 and 1. I'm sorry, I saw that 0 and I wrote down 1/2. Ooh, shame on me, it was 3 halves. It was 3 halves. And you all probably wrote it down like good students. All right, we'll adjust this as easily as we can. I'm sorry, I looked at the 0 and the 1 together and I said 1/2. But we're looking not between those. We're looking between 1 and 2. That's going to be 3 halves. So we'll just make your 1/2 of 3 halves, right? And then add, you'd get 3 halves. So just change your 1/2 here to another 3 halves. And then this would be a 9/4. That's an easy change. Just do that. And so then when you subtract it, that would be a negative 19/4. So just change that to negative 19. And then when you multiplied, well, you get 57/8 again. And so this is 57/8, and we would add those together, and it would be negative 57/8. So that's going to be negative 21/8. So we get the exact same value. Yeah, how about that? I don't know if it's a very symmetric graph, but a lot of different points have same values. There we go. We fixed our boo-boo. And I even have it written down here, by the way, which I forgot to read to you, because I'm trying to finish up the last one here. Right on this page, at the very, very bottom, once it decides to change page again, function crosses the x-axis at negative 3, 0, increases between negative 3 and negative 1. Right, that's why we have a positive y value for our first turning point, negative 3/2, 105/8. And the function decreases, it crosses the x-axis at 1, 0. Then it decreases between 1 and 3/2, and then increases to cross the function again. So we have a maximum and a minimum. Right, so let's look at all of our points again. So we had the 3x intercepts, negative 3, 0, 1, 0, and 2, 0. Our y-intercept is 0, 6. Right, so we had one relative minimum at 1.5 or 3/2. So this was 3/2 and negative 21/8. And then we had a relative maximum. This was negative 3/2, and it was, well, that's a lot easier to graph, 13.125, but it was 105/8. Right, there it is as a fraction. And don't forget those other 2 points we found. So here are extra points. We had the extras, and it was negative 2, 16, no, negative 2, 12. I just have to remember what my point was. And negative 1, 12. All right, let's graph those. So we have lots of points here. Negative 3, 0, 1, 0, 2, 0, 1.5, and that's negative 1.25. So right about there, it's negative 1.125. Which negative 21/8 is not right. Did I write down the wrong value from the other side, or did I just add it up wrong? Oh, why did I put 21? Maybe I can't read my number shoved in there, but that's only 9. 9/8. Well, I feel better about that. Negative 9/8. Because that was weird to have two values, again, with the same, two x values, the same y value. 3/2, negative 9/8. There we go. Man, whew. First I put in the wrong point, then I can't add. All right, so we have those graphed, and then our last little points are our relative maximum. We got that, we plugged in. So let's actually graph the negative 112 first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so my graph ends, and your graph probably does too. Because that will help you graph your last little point, which is 1 1/8 more. So now remember our shape, right? This is cubic, right? And the leading coefficient is positive, right? So we're going to start low, because f of x is going to go to negative infinity as x goes to negative infinity, and end high. F of x is going to go to positive infinity as x goes to positive infinity. All right, so make sure you start in the right direction. All right, so we're going to start low, and we have to cross. This was multiplicity 1, and keep on going until you get to the turning point. Turn, 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 turn. Woo, you made it. All right, so now my arm's shadow is blocking, so I'm trying to look for the point. And it's still blocking. There we go. All right, so here's our x-intercept. Multiplicity 1, cross. Turning point, turn, 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 turn. Multiplicity 1, keep crossing. And there we go. There's our SE-shaped graph. SE-shaped graph. Too many S's in that word. Domain and range are both negative infinity to infinity because this is odd degree and the ends are going in two different directions. And that's the end of this podcast. I have 2 more graphs in the next near pod, as well as just a recap of graphing. Thanks for watching and bye for now.